Okay, good morning. Yes. So in the last class, we went through machine learning, supervised machine learning. So you already understood the basics of machine learning, which instead of the normal classical programming where you have different if statements, do this, where you give it data and rules. With machine learning, you give it the data and the output, and then it should find the rules to get it from the data to the outputs. We went through supervised learning, which is basically teaching. So it's basically showing the outputs, and then it will show the system a different particular picture, for example, and say, okay, what is this going to be classified as? So we went through an example about cats, dogs, and so on. So we stated that we will first split our data set into, like, let's say 70% to train and then 30% to test. So when we're dividing our data set, the 70% can then be used to teach the system, okay, this is a picture of a cat and the output is a cat. This is a picture of a dog and the output is a dog. And then the remaining 30% you did not use to train, you use that to test and see how your model is doing. So supervised learning is basically giving it the inputs and the outputs and just basically training your system to understand that. So we'll go through a recap and then we'll look at how the code looks like in supervised learning, and then we'll move to unsupervised learning. So we also went through regression and classification. So regression is simply like a type of supervised learning where the goal is to predict continuous values. So like predicting the price of a house based on its features is like fitting a line to the data to make feature predictions. And there are different types of regression algorithms. We also have classification. It's just basically choosing the right category. For example, if you're trying to classify a picture as cats and dogs, the categories can either be cats or dogs. So it just depends on what you're trying to classify it as. And we went through different classification algorithms as well. So linear regression, for example, predicting house prices based on features like square footage, number of bedrooms. So one thing you can know, so let's say you're looking at, you have a house and you want to know how much that house will cost. You can use different previous data to try and estimate the price. So basically, you should know that as the size of a house gets bigger, the price might increase. There are also other features like number of bedrooms, number of floors, and so on. We also have logistic regression. So this one has categorical values. So the outcome can be two classes. And we went through an example like predicting whether an email is spam or not spam. So it can be based on different words. So let's say an email has buy this, buy that. It might be classified as spam than not spam. And it can also predict whether a patient has a particular medical condition. So you can classify a tumor as either benign or malignant. So is this harmful or not harmful, cancer or not cancer? And we also went through decision trees. So it's just using like a graph-like structure to try and classify something. So the example we used in the last class was a fruit example. So let's say you want to classify if something is an apple, if this particular fruit is an apple. You can have different questions like, okay, is the shape round? Is the color green, and so on. So that's decision trees. And we can also evaluate models. So remember, you're training with 70% of your data. So you're using 70% to teach the system. So remember, there are different train test plates. So you can train with 80%, test with 20%. It depends, but you should train with more. So you can also train with 90%, test with 10%. So the testing one, that's the one that you did not use to train. You can now use that to evaluate your model to see how good your model is doing. And with that, we went through different classification metrics like accuracy. So basically the amount of the test data the system got correctly. So let's look at the code. So remember, we'll use Python code for this. So it's going to also be available for you after the class. So just what we're getting into. So the data sets will have hours studied versus exam scores. So basically, if we want to try and predict the exam scores, the student exam scores based on the hours they studied. So it's just predicting outcomes using machine learning. So there are different coding tools you can use. So there's also one you can just use online. So there's something called Google Collab. So you just have to go to the browser and search Google Collab, and then it can open something for you. So if you have your computers here, you can search Google Collab. That's Google, then Collab, COLAB. So you click on www.googlecollab. Oh, sorry. Okay. So if you put this link in your browser, this should come up. Okay. So that's Google Collab. So I'll enter collaboresearch.google.com. So with this, you don't need to install all the Python installation toolkits. You can directly put your code here. So let me go back to the presentation. So one thing you should do is import the libraries you'll use. So we can import NumPy, we can import matplotlib. So NumPy is just to help you with different numerical operations. There's also scikit-learn. There are different data sets with scikit-learn, and you can have different machine learning algorithms. There's also matplot. So the matplotlib is to help you show a diagram. So anytime you want to plot something, you can use matplotlib. So one thing you can type is import numpy as MP. So I'll show. So you can put your code here. For example, import numpy as MP. So with Python, it's just using numpy, and then you're naming it MP here. So from your Python knowledge. So if you want to run this code, simply click this button here, and this will run. So once it finishes the run, you can put multiple lines of code as well, so you can import any other thing you want. So back to the code. So when you import all the libraries you need, you can then create the model. So here we can use linear regression. So for example, you can use the hours studied. Okay, sorry. So when you import the libraries, you can then create an array. So this one is just the data that we'll use. So this is just an example when you're going through it. So for example, let's say the student studied for 2 hours. You can predict their score to be 45%. When they study for 3 hours, 50%, 4 hours, 55%. So this is a linear regression. So based on a particular variable here, you can predict another outcome. So based on our study, you can predict a student's exam score. And you can see that these are continuous values. So they are numerical values. The output is numerical. So if they studied for 10 hours, their score can be 85%. So this is what you put into your code to train your model of how it can be used. You can also visualize your data. So remember with matplots, you can visualize your data. So if you remember from Python knowledge, plot.scatter can help you visualize. So if you want to plot hours studied versus exam score, you simply need to write this code. And then it can come this way. So if you're able to fit a line through a set of points, you can then have predictions. You can use this particular model to predict. So even though we've trained on when they study for 2, 3, 4, 5, 6, 7, 8, 9, 10 hours, you can also try and test or predict what their score will be if they study for 6.5 hours. If they study for 11 hours, what would their score be? So even though it's not in this particular training set, because you've been Okay. Okay. So sorry for the network connection. So we'll continue from this slide. So this is how the array might look like. So you might plot 2 hours against 45 percentage for the exam score, 3 against 50, 4, 55, and so on. So that's this plot here. So if you use matplotlib, the code here, you can visualize that particular array. So if you look here, you'll see 2 at 45, 3 at 50, 4 at 55. So this is just 5 at 60, 6 at 65, and so on. So this is just dummy data. So it's data we created. So this is how you can also create data. And after that, you can fit it into a linear regression model to help you predict on a new similar hour. So you can also you can predict, let's say someone studied for 7 or 8 hours. Can you try to predict that at their exam score? So remember linear regression, you can fit a line through a set of points. So this line simply means that when you have new data, you can, let's say you want to predict a student's score when they study for 3.5 hours. All you need to do is come to this X line here, 3.5, trace it up to this particular line, and trace it left. 5 hours, and you want to back left to see their score. So maybe they can get 82 percentage. So it's just an estimate. So so this one just has one particular feature to predict exam score. So for example, our studied is one, but for a more robust model, you can add something like knowledge about the course, prerequisites, and so on. We also have logistic regression. So remember, linear regression is for continuous outputs. So wanted to predict among a wide range of values. But with logistic regression, you have classification. So let me go to this tutorial. So let's say we want to build a logistic regression for Titanic survival prediction. First, you still import the necessary libraries you need. For example, pandas. So remember pandas for data manipulation. You can use scikit-learn for machine learning algorithms, NumPy for numerical computation, logistic regression. Remember previously we used linear regression because we wanted continuous outputs. You can use logistic regression for binary classification. So you can also load your data set. So this particular data set was carried out by Stanford. So let me open it for you. So this is how the data set can come in. So you can see whether or not they survive the particular class they were in, names, sex, age, siblings, parents, fair, and so on. So you can use this particular model to try and predict whether someone will survive based on particular features they have. So back to the tutorial. So you need to load the data set. So, and then you can use pandas to read the CSV file into a data frame named df. For data processing, you can select the relevant columns. So you can select the class, gender, age, fair, and whether or not they survive. So you don't need the person's name because someone's name does not have to do with whether or not they'll survive. But their age can play a role in whether or not they'll survive. So you can also handle missing values. So sometimes in your data sets, you might know that some columns, like in that CSV file that I opened, some of the columns might be empty. So for that, you want to be able to either drop that particular row or maybe put in the median value as a replacement anytime a value is empty. So for example, in this particular code that you'll get, we're replacing the age column with the median age value of passengers. And then we'll also convert categorical features like sex into numerical form using label encoding. So this particular part here, instead of using male, female, you can use 0 for male and then 1 for female, just so you can have better values and numerical inputs. And then also, you need to convert the survive column into binary form. So for example, 0 for not survived and 1 for survived. So if you're trying to predict whether someone survived or not, if your data set has words, for example, survived and not survived, you can use 0 and 1 for your classification. So it's common to present the target variable in binary form to make it compatible with the algorithms. So, and I remember we need to split the data set, right? So we'll split the data set into features and labels and further split them into training and testing sets. So remember with machine learning, you need the input and the output, right? And then it should help you know how to go from that particular input to the output. So it's commonly stored in a variable x. So anytime you have inputs, you'll see it's commonly in a variable x. So you can get all those columns like the age, the gender, their fair, and so on, and put it as your input features. So these are what you want to use to be able to categorize whether they've survived or did not survive. And then for the y, this is usually the output. So you can use y for labels or outputs. So you can store the survived column inside the y output. And then later on, so remember you need to split your data set into training and testing. So remember the reason for splitting is so you can use the test, that's one the system did not see, to find out whether the system is actually learning. So you can use 70% to remember train, that's teaching it, and then you can use 30% to test. In this case here, the test size is set to 0.2, so meaning it's just 20% to test, and that means you're using 80% to train. So remember, this 20%, it must not see it. As you're training, as you're giving the system, it must not see that particular value. So it's just like teaching in class or exam. So let's say after you teach in class, you might use a different set of questions to give students in exam to actually test their knowledge. So that's the idea behind training and testing. So, and then the same idea from linear regression, you need to build and evaluate the model. So remember previously with linear regression, we use linear regression, but if you're using logistic regression, what you have to do is put logistic regression here. Then remember .fit is actually to train it. So previously we put our training sets. So we made it X train, X test, Y train, and Y test. So remember we're putting the inputs in X and outputs in Y. So the inputs of what we're training, remember for the X part, it will have its own input and outputs. Sorry, for the train part, it will have its own input and output, and for the test part, it should have its own input and outputs. So you finish training it. So this .fit, you're basically using X and Y to train. It's basically like showing it the input values, and then you're going to also give it the output. So remember, that's how you teach. You do what? Give an example and then you show the answer to that. So that is the training part. So remember, we stored that here. So X train, the input of of the training set, and Y train, the output of the training set. So, and then now you can use the test set to try and predict. So remember, the test set, it did not see the output. So when we're training, we're showing it both X train and Y train together. So that's fit, this dot fit, that's what it means. And then when we're testing, we're only going to use the X test to predict. So this dot predict here, X test. It means we're only giving it the X test now. And then later on, we'll use Y test to actually compare what it actually outputs. So after we give it this X test, we'll now use an accuracy score to see how well it is actually doing. So this Y test, log reg prediction, that's this variable here. So from Python knowledge, this is what you can know. And then you can use a confusion matrix this way. So we're just using logistic regression, a simple yet effective algorithm for binary classification tasks. We evaluate the model's performance using accuracy and a confusion matrix. So in this tutorial, we've learned how to pre-process data, train a logistic regression model, and evaluate its performance using accuracy and the confusion matrix. So for this one, we can organize a separate online class to go through it in depth. So for today's session, we'll go through unsupervised learning, and then we can also organize an online class again to go through unsupervised learning, the code for unsupervised learning, sorry. So remember, with supervised learning, you're giving it what? The inputs and then the particular outputs. So you're teaching it that. But with unsupervised, you want to find structures within data. So unsupervised learning is a type of machine learning where the model is not provided with labeled training data. So you discover patterns, relationships, or structures within the data without predefined categories. So let's, for example, with our cats and dogs example, when we're trying to teach a system to predict if this particular picture is a cat or dog, remember before we'll give it a picture of a cat and tell it this is a cat. We'll give it a picture of a dog and say this is a dog. But with unsupervised learning, you're just going to give it, you don't have the labels. You'll not be able to tell the system this is a cat and this is a dog. You just give it all the pictures, but it should be able to try and divide it for you. The system will not be able to say this is a cat, this is a dog, but it should find the structure that's making cats and dogs different, but it will not know the outputs. So that's basically unsupervised learning. So for example, here you can, like for example, pictures of celebrities, you can be able to classify them, George Clooney, Brad Pitt, anyone. But with unsupervised, you're just trying to group similar people together, similar groups together. So if you're trying to use unsupervised learning for people, you should put similar people within one particular group. So remember, with machine learning, so there are different types of machine learning. So we have the supervised learning, develop predictive model based on both input and output data. And we have unsupervised learning, group and interpret data based only on input data. So with supervised learning, we went through regression, which is for continuous output. Oh, okay, sorry. So with supervised learning, we went through classification and regression. So remember, regression is for continuous output, so a wide range of numbers. So it could fall into 45, 55, 60, and so on. Price of a house can be 100 million, 120 million, just a wide range of values. But with classification, you know the particular, it's just discrete set of values. So it can be cats or dogs, cats, dogs, mugs, hats. It knows a particular class is going to fall into. With unsupervised, we have clustering to help us group data. So there are different supervised learning methods from the last class: nearest, mean, KNN, neural networks, decision trees, and so on. We have unsupervised, unlike a supervised neural network, a decision tree algorithm are not trained with examples of correct answer. The purpose is to find structure within a set of data where no one piece of data is the answer. So this is an example of data clustering, just grouping similar groups together. So clustering is the task of grouping a set of objects in such a way that objects in the same group, called a cluster, more similar in some sense to each other than to those in other groups. It is a main task of exploratory data mining and a common technique for statistical data analysis used in many fields such as computational biology, image analysis, and many more. So with data clustering, clustering is used frequently in data-intensive applications. We have market research. Retailers who track customer purchases can use this information to automatically detect groups of customers with similar buying patterns. So you might want to put particular. So let's say a user has bought this particular top before, and let's say you now go on the site and you buy this top. You because you might be in one cluster. So social network, there's also social network analysis to create a more relevant set of search results compared to normal search engine. Okay, so remember with data clustering, it can be used for different applications, market research, social network analysis, recommendation systems, and crime analysis. So we have different types of clustering. There's hierarchical clustering and there's also k-means clustering. So hierarchical clustering is just merging different groups together. With k-means, it's a popular and supervised clustering algorithms that partitions data points into k clusters. So groups data points based on similarity with each cluster represented by its centroid. So for example, this is how clustering might work. You have different data, A, B, C, D, E. So this can also be people. You just need to put different points. Like, let's say you want to classify it into these people into two different clusters. You then put two different points. So that's this particular point here and then this particular point. So the next thing you do is try and put the people or this data that are close to this point, and then the ones that are close to this point, you put that there. And then after that, you now put those points in the center of, let me say, those people. So these particular points will move here. These particular points will move somewhere here in between. And then you repeat that process again. You put the people, let me see, these points A, B, C, that are closest to this one in 1, and D and E that are closest to this one in 1. And then you repeat that process. You find the middle point of all these A, B, C, and then you put it there. Find the middle point of D and E, and you put it there. So if you try the same thing again, A, B, and C will still be in this particular cluster. D and E will still be in this particular cluster because the first point has A, B, and C closest to it, and the second point has D and E closest to it. So that means you found your clusters. You're able to group this set of points into two different clusters. So that's basically k-means. So it just depends on the number of clusters you want. If you want two different groups, you use two different points. So if you want three different groups, you then use three different points. So there's also like a code example. So this one is just generating a synthetic data set with make blobs from sklearn dataset. You can visualize around is k-means. So if we want to use k-means, we use k-means just like how we use linear regression and logistic regression. And then this make blobs is just to help you make different data sets. So this time around, we're generating our own data sets. So it's not a real one, but we'll work with a real one at the end. So first, you can make different blobs. So if you want 300 different points or different data, you use 300, 3 centers. And the random state is just to make sure your anytime you run the code again, it's going to give you the same random number. And then remember, from data frames, you can also put this in features, columns feature 1 and feature 2. So there's also explanation of the code as well. So you can also plot the blobs this way. So if you're plotting the blobs, this is what it can give you. So 300 different data points, and I said 3 clusters. So that particular code will give you something like this. Yeah. So and then you can use this to decide to group different clusters together. So remember, you can also run k-means. We want 3 different clusters, and then we want to fit. Remember, the dot fit is like saying train this. So previously in the logistic regression code, we had both the train and the test. So we had train, x train, comma, x test. Sorry, x train, comma, y train. X train, comma, x test. So that means we are doing what? Training what? The x data set with what? The training one with what? The test one. So we are teaching it, this is the input and then this is the output. So, and this dot fit is basically saying train. So here, this time around, we don't have what? The output, right? So we're just going to use the input only, the x, because we're using clustering. It doesn't come with labeled outputs. So there's also summary of that as well, and then we can also plot here. So we'll go into more depth in a separate online class because it will take more than an hour to go into each particular code. So there's also an iris data set example. So use the iris data set from sklearn. You can also visualize 2 features, sepal length and sepal width. So this particular one is a real data set. It's the iris data set for flowers. So remember how flowers can come with sepal length and sepal width. You can also decide to put different flowers together or similar groups together. So you can use k-means clustering to identify these clusters. You can also use this particular code for that. So you load the iris data sets, and then you can put that in the data frame and so on. And then you can also plot the data sets. There's also explanation for this. So these are iris sepal features plots. So remember, if you plot, you can visualize this here. So this is the sepal length. So it can come in, you know how that CSV file I showed look. So it can come in length and width in a column. So let's say a sepal length of a particular flower is about 4.5, and the width of that particular flower is 2.3. So that's just this plot. You can have another flower with sepal length 5.0, and then the sepal width is 2.0. So that's just what this particular plot means. And then k-means clustering on iris data set. So you can apply k-means clustering to this iris data set, visualize the clusters and then the cluster centers. So this k-means here, remember if you want to use k-means algorithms, you write k-means. And then this n clusters depending on the number of groups you want. So if I put 3 here, it simply means I want 3 clusters. If I put 2, I want 2 clusters. And then random state 42, just generating the same random set. And then this dot fit, so remember it's to train. It doesn't have its output. That's why it only has one data. So it's something like this. So when you group everything together with that particular plot I showed before, remember it was all blue, but this time around, if you want 3 different clusters, you can group it in this particular way. So you have one cluster here, another cluster here, and another cluster here. So this is just how k-means will work. So also there are also some overlap here. So this particular flower has similar length and similar width with this particular flower. So that's why there's an overlap with the blue and yellow here. But in general, most of that particular the purple one is going to be smaller than the yellow one. So you can also remember plot new data. So let's say you have a new flower, and then that particular length is 5.0, and then the width is 3.5 here. Since this one is closest to this cluster, you're basically going to group it with this particular one. So similarly, if you have a new user and their features are closer to another user, you just need to group them with that particular user. So this one here has a longer sepal length and an average sepal width, so you group them with the yellow flower. So this is just how clustering works. So the new data will be classified or grouped with the previous data you trained on. So just conclusion, we were able to go through unsupervised learning. So basically, you need to find structure within data, and then there are different types of clustering algorithms. So you can have hierarchical clustering, k-means, and so on. So it's just to group similar data. So any question so far? Okay.
To check the YouTube questions.
Oh, okay. Okay, sorry. Okay. Okay, so when you're training it, you're going. You mean if somebody mistakenly does? Oh, okay. So let's say one thing that can happen is because you have like a lot of data sets. Okay, any? Okay. Oh, okay. Okay, from the okay, you mean the first class. Okay, we can organize an online session. So maybe we'll just communicate on the platform. Okay. Okay. Oh, okay. So the Collab tool is just like an IDE. It's not it's just a place for you to place your code and run your code. So it's just that you don't need those Python installation. So if you open that particular link, um, if you open this, all you need to do is paste your Python code, and then when you click run, you can run. So if I let's say if I print something here, and is even if it's not Python knowledge, but coding knowledge. So knowledge about variables, arrays, um, um, uh, and then so if you have like coding knowledge, you can easily convert it to the Python knowledge. So I'll just explain the lines of code. Okay, this is a variable, this is the input, this is the output, and so on. Thank you. Thank you. Unsupervised? Okay.
For instance, if we have 70% friend and 30% non-friend data.
Okay.
So how can we, like for instance, if we are to so if we are to maybe filter, let's if maybe for instance if they want us to maybe the pass marks is between those that are maybe a friend and content, the pass mark is maybe is between 60% and above. How can we filter out the schools in between this thing, the result? That is the hours of training and this thing.
Okay, like hours studied versus
Yes.
the exam score. Okay, like you want to only stop at 60%.
No, what I mean is that if maybe for instance we say that maybe the pass mark is from 60 and above, to filter out those who have maybe have above 60 marks.
Oh, okay. So that particular example, it was just to predict different continuous value. But if you want to predict whether they pass or fail, then you use classification. So this time around, for the hour study, if they have a higher hour study, you can use, let me say, 1 for pass. Like instead of using like their exam score percentage, like 45%, 55%, 60%, instead you use zeros and ones. So you can say 0 for fail, 1 for pass. So if the hour studied is like 9 hours, you can say, okay, you give it a value of 1. If the hour studied is 1 hour, you give it a value of 0. If it's 1 hour or 2 hours, it's value of 0, and so on. So that way you're then predicting whether they pass or fail. But if you, that's logistic regression, whether they pass or fail, because you want to put that in a particular group, a particular discrete label. But if you want to predict their score, a continuous range, then that means that's linear regression. So if you're using linear regression, you can say their score is 20, 25, 30, 32, 33, just a wide range of numbers, numerical value. But with the categorical one, if you want to know whether they will pass or fail, you use logistic regression. So you can classify as 0, classify as 1, just like that. So anytime you see they studied for 2 hours, you can put the class as 0. For 4 hours, class as 0. If they studied for 11 hours, class as 1, and so on. I don't know if I answered your question. Okay. So any question? So let me just check the online comment. Okay, so a question, what is the reason behind the use of unsupervised learning by AI? So it's just if you want to group similar data together. So the market research, we have the recommendation system. So remember with Netflix, if you want to be able to build something that can recommend your products or any of your products to a particular user, you can use unsupervised learning because it will group similar users together. So any more questions from the online class? So the lecture notes will be so yeah, we can have an online catered to you on the platform. Materials will be posted as well. Practical classes. So let's say you're new to Python. I'll post where you can learn some basic knowledge of Python. Okay, you can also have a step-by-step approach. So there's a tutorial for that. So letter K in clustering just simply means the number of clusters. So K just represents the cluster you want. So if you want one cluster, if you want to group within two, if you want 3 groups, K is 3. So K just represents the number of clusters. So that's the K means. Uh, so you use label encoder to convert. If you have a male, female, you can change it to 0, 1, and so on. Yes, it's also suitable for the target variable. So with this, for example, not survived can be converted to 0 and survived can be converted to 1 in the logistic regression task. So difference between regression and linear regression. So regression is commonly used for continuous tasks. So there are different types of regressions. You also see that in the notes from the last class as well. You'll see the different types of regression. There's lasso regression, ridge regression, and so on. Sorry, I think I missed your question. In the field of NGO, let's say you want to and it also depends on what you're doing. Anyone, people who need food, Okay, so thank you very much. Okay, so okay, yes.
Khadija for that nice attendance. Please go to the Telegram group. We always drop the link for the attendance to sign up your attendance. Yeah, always go to remember to go to the Telegram group. Note that your Telegram group is where we pass information regarding anything that has to do with classes. So instead of coming to the YouTube and be asking where is attendance, always shuttle between the Telegram group and your YouTube. And also remember to always subscribe to the YouTube page so that you can get notification for classes. So that you won't be waiting for the YouTube link to be sent to you. So once you subscribe, that is for online students. Once you subscribe, you always get notification for classes. And so it's very easy for you than going to the Telegram group to be looking for a link to click. So now, as you're on the YouTube page, make sure you subscribe to the page so you can get notification for classes. That's all for now. So the next, those who are for blockchain, get ready. Your class is next. So that's all. The name of the page